Yes, hello and welcome. In the previous classes, we looked at base numbers and we were able to convert from one base number to another. So in this class, we're going to try to solve some problems and at the same time revise what we've done so far, even as we try to introduce a new concept today. Okay, so before I start, I'm going to ask some few questions. Oluwa say, I don't know whether can you hear me?
Yes, sir.
Okay. So we're gonna try solving some problems.
Okay, sir.
And I'm gonna ask some questions.
Okay, sir.
Now, what are the two most popular counting systems in the world? What are the two
Binary,
most popular counting systems in the world?
binary system and denary system.
Perfect. Binary system and denary system. And in binary system, we mean counting in base what?
1 and 0.
1 and 0. That's base 2. Just 1 and 0. Now, when we say denary, what are we counting in base what?
0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Shara.
Good. That is base 10, isn't it? Don't worry, I'm eating now. I'm very hungry. So I'll be eating while we discuss. Now,
I said it.
if you want to convert from one base to the other, what is the most likely base that you need to take it to before you convert to the other one?
Base 10.
Good. So base 10 is like the basis on which you can convert from one base to the other.
Yes, sir.
And that is why it's very important that you learn about base 10. Now, if you want to convert something to base 10, which method do you use? Is it repeated multiplication or repeated division?
Repeated division.
Okay. And if you want to convert back to the other base, you use what?
Repeated multiplication.
So those are the things we learned the last time. Now, what are the numbers that we are likely to find under base 7?
1, 2, 3, 4, 5, and 6.
You not start where you're supposed to start.
Sorry, 0, 1, 2, 3,
Come
4,
again.
5, and 6. 0, 1, 2, 3, 4, 5, and 6.
Good. You must start from 0, then to a number that is 1 less than the base that you are considering.
Yes.
So what are the numbers under base 8?
0, 1, 2, 3, 4, 5, 6, and 7.
Good. So with that, we can start now. Please let me know when you can see my screen.
I'm seeing it. Okay, there's not something there.
Sorry, I'm being distracted a little bit. Okay, so let me go through now. So this is what we did the last time. It has various numbers you can see under any bill. And these are some of the calculations we did. Okay. To convert from base 10 to base 8, so you have to repeatedly divide by 8. We've done this already. But to convert from another base to base 10, we have to do our multiplication, putting the right place values. And we now did conversion of a number in one base to another in another base. Okay. So, Oluseyi, can you explain to me how to convert 134 base 5 to a number in base 2?
First of all, you have to convert it to base 10 by using repeated multiplication. Then when you are done with that, then use repeated division. So that I can be able to convert it to base 10. I mean to base 2.
You now use repeated division to convert from base 10 then to the base they are looking for, which is
yes, sir.
to Abi. So that's the case. Okay. Okay, so let's look at this problem. So this is a peculiar problem to base numbers, and most likely that's the kind of problem that you see in JAMB. So you have if 3, 2, 4, 9, find x. How do you think we should approach this?
You use repeated multiplication, but you just have to arrange the numbers on top. It's not hard. Okay.
Come again.
I thought you use repeated multiplication too. To convert it to base 10. Wait. So we have to convert to base what? 9, Abi?
Yeah, you want to get to base 9.
Yes, you first convert to base 10. You first convert to base 10 before converting to 9.
And from base 10. Yes, that's it. And that's actually what was done there. Is it clear?
Yes, sir.
You can see this is conversion to base 9 using repeated multiplication with the base being the base that is in question. So you have 3 times 6 to power 3 because you have 3 here. Times 6, which is the base, to power the number of numbers in front of 3, which is 1, 2, 3. So do same for the second number, which is 2 times the base, which is 6. How many numbers in front of 2? 1, 2. So once you do it, multiply out, you get what is it in base 10. Then whatever you get in base 10, now convert it to base what? 9, which is you can do by what? Repeated division. Abi?
Yes, sir.
Is it by repeated division? Then you collect the remainders from down up. Abi?
Yes, sir.
Is that? So this is the number you get, 1011. So can you get how you can solve such problems? In case if you see them in that,
yes,
clear
sir.
how you can. Yeah.
Yes, sir.
So let's continue. Okay. Okay, there's also another thing known as conversion of decimal number to base 10. So this one does not normally come. Let's take a look at it. So for you to do this, you have 0 and 1, 2. So what this one, if you want to convert it, it does the same way. You still write 1 times the base, which is 2, times how many numbers are in front of 1? 1, 2. So you do the second one. The second number is 0 times the base, which is 2. How many numbers are in front of 2? In front of 0, 1. And the last one, which is 1 times the base, which is 2. How many numbers are in front of 1? 0. Now, plus. If you want to start considering numbers after the decimal point, then it has to be you have 1 times 2 to No, this is where we have 0, which is the first number after. So, very importantly, you just need to check. Here you have the exponents. You have 2, 1, 0. That means the next one is going to be -1, -2, then -3. So take note. So for this 0, you're going to have 0 times 2 to the power -1. Then for this one, you're going to have 1 times 2 to the power -2. Then for this other one, you're going to have 1 times 2 to the power -2. So whenever you're doing for decimal numbers, you have to just check. You have to do the first part for the test, just the normal way you would have done it before. So for normal integers. But once you get to the decimal point, since you've reached 0, for subsequent numbers, you're just going to increase 1, but making sure that they're in negative. So that's how you do that. So now sort it out. Just the normal way you solve your normal indices and get back to it. So, Oluwaseyi, I don't know whether you understood this. Gosh, I didn't get you.
I said I understood what you're saying.
Okay. Network is not very strong. So that's how I'm about it. So let me check out it. Okay, this is another example. Like I said, it's just the similar thing that they did here. You have 241.23 to the base of 8. So since the base is 8, we'll take the first number 2 times 8 to the power. How many numbers are in front of 2? 1, 2. Second number is 4 times the base, which is 8. How many numbers are in front of 1? 1. And the third number is 1 times the base of 8. How many numbers are in front of 1? 0. Now this is where we stop. So once you stop here, you see that you've gone from 2, 1 to 0. So next thing will now be -1, -2. So that's how you go about it. So you put the next number, which is 2, but because it's on the other side, it has to be -1, and the other one -2. So when you sort it out, then you get this thing. Okay. Another one. If you get this, is it better? Is it better with one example? Okay. So we are still trying to explain the same thing. Okay. So let's look at this one now. You can see that this one is not having any number here at all. It does 0 points. So you can as well say 0 times 5 to the power 0, which will also give you 0. That's why they forgot about it totally and started from the dot. I know after the dot, anything you have is -1, -2, and -3 down well. So that's why you have 1 times the base, which is 5 to the power -1, plus the second number 2 times the base, 5 to the power -2 times 4 times plus 4 times 8 is 5 to the power -2. So you know that once you have minus to power minus something, you can easily change it to 1 over that very thing. So that's why all they had here. That's how they got about it. Do I see this one clear?
Sir?
Is it clear?
Yes, sir.
Money somewhere.
Okay, so let's look at conversion of fractions of decimal numbers in base 10 to base 2. How do you convert fractions? Most of these don't come out. Okay, let me just scroll down. Make sure that we're doing. Okay, so let's get to the topic of today. We just rounded up some problems.
Hello?
let's get to the cross of the matter. Yeah, let me get your question.
This will most of them are using wireless. Is it up? No. Look at you. I saw it in the Facebook.
Take note of 2F. Take note of 2F. You want to ask us questions, or do we continue? Okay, let me continue. Let's look at this very important topic: fractions, decimal approximations, and percentages. Very important. They come out every time. So what is a fraction? Fraction is a part of a whole expressed as a figure placed on top of another figure. So these are examples of fractions: 2/3, 4/7, 5/9. Oluwase, give me more examples of fractions. Let's include them here.
3/7, 2/8, 1/9.
3/7, 2/8, 1/9. Okay, so these are all fractions. And these are what we call proper fraction. Once the numerator is less than the denominator, call it proper fraction. Okay, there are essentially two types. You have the proper and improper fraction. A proper fraction has the numerator less than the denominator. So all these examples are all proper fractions because the numerators are less than the denominators. Why an improper fraction has the numerator greater than the denominator? So you can see that these are improper fractions. So Oluwase, give me more examples of improper fractions.
9/7, 10/8,
9/7.
10/8,
Okay. Over what?
10/8,
8. 10/8. Okay.
16/14.
16 over what?
14.
14. Okay, good. All these are improper fractions because they actually the numerators are greater than the denominator. So numerator is the number up before the division sign. The denominator is the number down after the division sign. So take note. It's good you know this before you go into the property. Now that leads us to what we call BODMAS. How do you simplify fractions, combinations of fractions? BODMAS. Now, also we have a mixed number which consists of a whole number and a fraction written together. So this is what we call mixed fraction. Oluwase, this is what we call what?
Mixed fraction.
Mixed fraction. When you have a whole number, then you have a fraction attached to it. Now, solving problems involving fractions does not create any difficulty once a student remembers the word BODMAS. So you must remember the word what?
BODMAS.
BODMAS. That's what you use in solving fractions. Once you remember it, it makes the work very, very easy. So what does this word BODMAS stand for? And this word BODMAS, exactly the way it is written, that's how you're gonna take the fraction, exactly the way it is written. So B in BODMAS stands for bracket, O in BODMAS stands for off, D in BODMAS stands for division, M in BODMAS stands for multiplication, A stands for addition, S stands for subtraction. Now, if you have a combination of fractions where you have some enclosed in a bracket, the one in bracket has to be solved first. If you have a statement that says off, that off has to be solved first. And you know that off in mathematics simply means times. Then after that, you look for where the division sign is. That any combination that has division sign is the next to be solved. Then after that, you look for the combination that has the multiplication sign. That has to be solved. Then any combination that has addition, and finally subtraction. So that's why whenever you hear simplify this, you must first of all write the word BODMAS. Then you start solving from the bracket down. So you must follow them in this order. It has to be followed. So let's take an example to understand this, okay? So this is the typical simplification of fractions. You can see there are a lot of fractions here. So we're going to apply the principle of, I'm going to write it now, BODMAS. This is what we're looking at. So Oluwase, we're going to solve this together. This is the last we are going to do for today because we looked at this number. But I want you to get into it and be able to understand it before we sign off. Okay, because I wanted us to get more past questions from these numbers before we dive deeply into this. So Oluwase, tell me now, using BODMAS, which should I look at first?
Of the bracket first. After the bracket, then off.
Huh?
The bracket first.
Good. So we're going to look at all these things inside the bracket. So we're going to forget about 5 whole number 2 over 3. Can you see the way they forget about 5 whole number 2 over 3? It's the same thing here, it's the same thing here, it's the same thing here. This is where they started working on it. Because they have to leave it and first of all work on the bracket. Oluwase, is this thing clear?
Yes, sir.
Okay. So now that we've known that the one in the bracket is the first one to work on. So forgot about this and we concentrated here. So these are what we are concentrating on. So now, which one do we solve first? Now that we are inside the bracket, because it's the bracket that we're supposed to solve first. Which do we solve first? There's no plus here. It's off. So which one do we solve first?
Of the one of 23 number 2 over 5 of 3 number 1 over 4.
Good. So we'll look at the two fractions that are related by off. That's the next thing. Because that's the next thing after BODMAS B. So now it's these two that we have to sort out first. So that's why we started solving them first. So forget about this 22. It's not important in this series. That's why we left 22 exactly the way it was there. You can see 22 is left the way it was there. 5 whole number 2 over 3 is left the way it was. But these two we are worked on first because off is the next thing. So for you to solve any mixed fraction, you might have to multiply out by saying the denominator times the normal number plus the numerator. That's what will stay on top. So if you say 5 times 23 plus 2, you get 117. All over, you still return what the denominator was. And that's what they did here. 4 times 3, which is 12. 12 plus 1, 13 all over 4. So that's how they got about it. Is this clear?
Yes, sir.
Luashe, is it clear?
Yes, sir.
So having done the off now, what's the next thing? We need to multiply them out because I told you that off is the same as times. So if you now do 117 times 13, you get this. 5 times 4, you get 20. So now you can now work again. But you have to first of all finish everything that is inside the bracket before you start relating because there is still bracket here. So how do you do this now? The next thing will be division. After O, what's the next thing? Is it division?
Yes, sir.
Okay. So you can get this out. But whenever you have just two numbers like this, you can make can take the LCM and get it out. So you can simply say 20. The LCM for 20 and 1 here is 20. So you can simply say 20 times 22 minus 1521, which is actually what they did here, over 20. So if you subtract out, you have 1081 all over 20. And that is only when you can now relate it to what we have here. So you can now solve this out. So to solve this out, you have 5 whole number 2 over 3. So to multiply, we have 3 times 5 plus 2. 3 times 5 is 15. 15 plus 2 is what? 17. 17 all over. Okay. Then you can now relate the two of them because there is no bracket again. So that means that what we are supposed to have here is always times and not plus. Okay. So if you multiply out now, you have this. So I don't know whether is it clear? Actually, is it clear?
Yes, sir.
So basically, what we consider is we need to take it one by one. Consider all the fractions inside the bracket to solve out. So as we are solving, we're also maintaining this. We are checking where there is off first. So we have to sort out the off first. Before we sort out the division. Then if there is any multiplication, we'll sort it out. Then if there is addition, we'll sort it out first. Then we'll sort out subtraction. So once we're done sorting out everything that is in the bracket, that's when we can relate it to something that is not in the bracket. Also still maintaining BODMAS. Then we can now put them together. So that's how you solve BODMAS. Okay. So this is the last one before order of magnitude. So in the next class, we're going to be looking at order of magnitude. But I want you to solve this as an exam, as an assignment. As I'm looking at it now, during the typing, there were typographical errors. So, Oluwaseyi, I want you to solve this problem. Stephen, I also want you to, both of you should quickly solve this on your paper. Then me and you will now follow it out and solve it out very well. So solve on your paper now. Then tell me where mistakes are. I think the final answer will still be the same thing, but there are some places we needed to sort out. So let it be the assignment.
The screen is not too clear. Sir, the screen is not clear. Is it one or number? Read the question.
Okay, the question says 1 whole number 1 over 4. So I'm going to write out the question here. 1 whole number 1 over 4 plus 1 whole number 1 over 2. Okay, now everything here all over 5 whole number 1 over 8. 5 whole number 1 over 8 minus 3 whole number 3 over 4. Okay, so that's what we have. I don't know whether this one is clear. Oluwaseyi, is this one clear?
Yes, sir.
Okay. So solve this. Let's see. Solve it and tell me the answer. Then tell me how you've gone about doing it. Yeah, good evening, sir. I know. I wanted to even call you. Yes. Yeah, they've started. We are supposed to send, I sent them mail yesterday. So they say I'm supposed to use the mail that we used in processing the pin to send the mail. So it has to be through your mail. So I don't know if he's around, he can just come because the ones who just send, they send the pins immediately. Come so that, come now. I'm at the office so that my boy will help you. Yeah, Oluwaseyi, once you're done, let me know. Stephen, once you're done.
I'm done, sir.
Okay, you're done. Oh, yeah, let's go. Let's go now. So I'm going to be typing. You'll be telling me what to type. I'll be typing.
Okay, 4 times 1, 4 plus 1. I'm considering the numerator first.
Okay, you're considering the upper one first, Abi?
Yes, sir.
The numerator first, yeah. So that is, it's normal to consider the numerator first. So what should I write now?
5/4.
5/4, thank you. So that's the first thing, 5/4. So why am I writing 5/4? Because you sorted it out, you said this is a mixed fraction. In order to get a mixed fraction down, you simply say this 4 down here times 1, which is 4, plus 1, which is 5. So that's why we have 5/4. I hope that's what you did, isn't it?
Yes, sir.
Okay,
Plus
so
3.
let's get to the next one. So what should I write now?
Plus 3/2.
Plus 3/2. So I guess the way you got the 3/2 is by simplifying the mixed fraction. The mixed fraction is one whole number, 1/2. So get it out. You say the denominator times the whole number, which is 2 times 1, plus the numerator, which is 3, all over the denominator, which is 2. Is that what you did?
Yes, sir.
Okay. So let's move forward. So I'm going to now put the division sign, which is the big division sign. Then we'll do the denominator now, Abi.
Yes, sir.
Okay, so let's sort it out. What should I write now?
41/8.
31.
41.
41, okay. 41 all over what?
8.
8, okay. So how did you
Minus
get about
50.
41/8?
I said 8
You
times
simply say
5.
8 times 5, which is 40 plus 1, 41 all over 8. So that is perfect. Now minus, what did we get?
15/4.
15/4. And how did you get 15/4? By simplifying the mixed fraction by saying 4 times 3, 12. 12 plus 3, 15 all over the denominator 4. Is that what you did?
Yes, sir.
That is perfect. So what's the next thing to do now? Tell me.
Then I would collect look for the LCM for the numerator first, then for the
Good. You
denominator.
look for the LCM of the numerator first, then later you do that same for the denominator, is it not? So what's the LCM for
Yes,
4 and 2? The two of them is 4 and 2.
4.
It should be 4, isn't it?
Yes, sir.
Okay. So what are we supposed to have now?
5 plus 6/4.
Okay, I can have now 5 because if 4
Plus
divides,
6.
okay, plus 6.
6/4. Yes,
All over
sir.
what? All over
4.
the LCM, which is what? 4.
4.
Abi? So how we
Yes,
got
sir.
6 is that 4 divided by 2 is what? 2. 2 times 3 is what? 6. That's how we got that, okay? Then we can move forward and put this very big division sign and work on the denominator. So what's the LCM for 8 and 4?
8.
8, Abi? So what will
Yes,
we
sir.
get now? We will now get what? 41. 41 what are we getting?
41 minus
Minus
30/8. 30.
30. Okay, why are we using 30? Who can tell me why we're using 30? We are using 30 because we have what? 8, which is the denominator, Abi, which is the
Yes, sir.
LCM. 4 into 8. 8 divided by 4 will give us 2. So 2 times 15 will give us 30. And that's how we got it. Okay. So moving from here now, what do we get now?
For the numerator, we'll get
5 plus 6, Abi.
yes, sir.
5 plus
We'll
6
get
is what? 11.
11/4.
Abi?
Yes,
So
sir.
we have 11/4 and massively divided by what?
11/8.
41 minus 30 is what?
11.
11 again. All
Yes,
over
sir.
what?
8.
8. Abi?
Yes, sir.
Okay. See? You see that we're coming at this 2 now. So what next do we do?
We'll say 11/4 divided by 11/8.
So we have 11/4 divided by what? 11/8. So we have 11/4, Abi, divided
Yes,
by 1/8. But if you want to remove divided by and change it to times, which is what we want, you will now have to
yes.
You have to invert that 11 over 8 to what? 8 over what?
Which
8 over 11.
8 over 11.
Are you aware of this, Oluwaseyi?
Yes, sir.
You know that whenever you want to change a division sign to multiplication sign, you have to invert what is following the division sign. Are you aware?
Yes, sir.
Okay, so with this, it makes the work very easy because now 11 can cancel out 11. Are you aware?
Yes, sir.
And 11 cancel out 11. So we are now having only what?
Yes, sir.
8 divided by what? 4. And 8 divided
4.
by what?
That's
4 is equal to what?
2.
8 divided by 4 is equal to 2. And that's how they got this 2. Okay. So that's what happened. And that is how you solve simplification problem. Okay. So we're going to be rounding off here. In subsequent classes, we're going to solve detailed problems in base numbers. I will go deeper into this. Thank you. See you when I see you. Thank you. God bless
Sir,
you. Yeah. I want to ask me a question.
not question. I sent something on the group, but you've not replied.
Huh?
I sent something on the group. An assignment.
What?
I did not get it. I sent something on the group. My assignment. I could not get it.
Okay, you sent me an assignment on WhatsApp. Okay, on the group. Okay, it will be worked on. Yeah. Don't worry. After this class, immediately go check back. I will tell somebody to work on it.
Okay, sir. Thanks, sir.
Yeah.